Okay, so let's look at voltage and current. Okay, so voltage can be separated into two more types. So there's potential difference and there's EMF. If you call it voltage, that's okay. Okay, so what happens, let's have a look at a model and how this thing sort of works. Okay, so let's have a look at a cell. So here's our cell. Now what happens is, inside the cell, we convert chemical potential energy into electrical potential energy. Okay, so what happens is, let's say a whole lot of stuff is moved from one end to the other, and now we've got a build-up of stuff that wants to explode. Now, the size of that build-up is your voltage. Okay, more specifically, it's the EMF. Okay, so this is the size of energy converted to electrical potential energy per charge carrier. In other words, the things that fly around the circuit. How much energy does each one have? A sort of like, what we could have is a mountain, and on the mountain we have a chairlift. So these are sort of chairlift. Okay. And what happens is, each little charge carrier, so each person going up the chairlift, is going to gain a certain amount of gravitational potential energy. So it could be, let's say, 2. So we could have 2 gravitational potential energies per one person. And so that means we have a voltage of 2, or an energy of 2 per person. Okay? In the case of the voltage on this side, it is the amount of energy per charge. Okay, so how much energy each bit of charge that flows around a circuit is carrying. And what type of energy? Remember, it's electrical potential energy. Now, the skiers have got to the top of this mountain. Okay, what do they do next? Well, they ski down the mountain. Okay, so as they ski down the mountain, they're converting this gravitational potential energy into kinetic energy. And that kinetic energy is effectively lost as some sort of maybe sound and heat as they're going down. So in our circuit here, if we now continue the wires from our cell, and we have, let's say, a light bulb in the circuit, here's my light bulb. That's a pretty average light bulb. That's my light bulb, okay, in the circuit. Now, once we've connected the circuit, we've now given a route for the charges to flow to balance out again. So they're going to flow. And what we're looking at here is the direction of a conventional current. So conventional current flows around this way from the positive end to the negative end of a cell. So we're flying around, and as these charges, these little carriers, they're flying around, as they go around the circuit, they drop their energy off. They convert it to another form. In a light bulb, it's released as heat and light. A light bulb actually gets to about 2,500 degrees. There's actually a lot of heat there. So these are charges lose their energy. So here, they have gained, let's try a different color, they have gained some energy, okay, inside this cell. They then fly around, and then they lose the energy. Then they fly around, and then they gain the energy, fly around, lose the energy. And it's a continuous cycle. When the energy comes out, that is also a voltage, and in this case it is the potential difference. So it's EMF is the energy provided to the charges, potential difference is the energy taken from the charges. So on our skier, the EMF is the amount of energy that these charges gain as they get to the top, in this case 2, and then as they fall down, just because of conservation of energy, they must then lose that 2 that they gained in the first place to be left with 0 again. So they lose that 2, so that means that's their potential difference. They've lost that much potential. Okay, so they've lost 2. So that is the voltage. Voltage is the energy provided in versus the energy provided out. Now what you can do, let's say we were lifting up marbles onto a track. Okay, so what we have is a ramp. Okay, and inside the ramp there's lots of nails. We'll do this in class. Now what we do is we lift up a marble from here up to here. It gains gravitational potential energy. So this gain in energy per marble is our voltage. Okay, this is a model. This means it is a representation of a circuit. It's not actually a circuit. We don't have marbles flying around the electrical circuit, but this is a model of one. So we have a marble, we lift it up, it gains energy. This is EMF. This is your voltage in. Okay. Now, depending on the slope and how high you give it, let's say we gave it lots of energy, okay? We raised the slope up and we got to here. So our slope was much higher. If we raise it up to here, at this point, at number 1, there is more energy. There's more voltage. 2, there is less voltage. Okay? So the higher the ramp, the higher we lift it in the first place, the greater the voltage. And you should know that the greater that voltage, the faster the marble will roll down the slope. Okay? So it'll get up to a higher speed down slope 1 than it would down slope 2. Okay? So this is fast and this is slow. Now, what is the speed? This flow rate? That is current. Okay? So, how fast these things flow is the current. Now, as these things go down, they lose energy. Where do they lose energy? You'll see in class they're actually going to smack into these nails, and they release energy as sound and heat. Okay, so they release the energy. And that is also, remember, a voltage. And this is your potential difference. Okay, so voltage, energy out per charge, or marble in this case. And this one is energy in per charge. Okay. So what do we know? We know the greater the voltage, the higher the current. Now current has the symbol I. Okay. The greater the current. Okay. So the greater the voltage, the greater the current. The more energy you provide to somebody, the faster they can go. Now there's another aspect you can have here. If we lift up 2 balls at the same time and get to the top, well then you actually have a greater current again, because if you have 2 balls flowing down the ramp at the same time, we now have 2 charges going down the ramp per second, maybe than we had 1 before. So you can also increase the number of charges you move to increase the current. But it's also related to the voltage.